Okay, hello. So this is installment 3 on our simplifying square roots. And I'm going to show you two methods that I would use to simplify. And the first one that I'm going to show you is called the prime factorization method. That's what I call it. It doesn't really have the name, I don't think. But this method, some of you will like, some of you won't like, some of you will use it the whole time. But when we start doing those rational exponents I was showing you in the last video, this method really does come in handy. And I think it might be easier. So let me run through this for you and just kind of share what you would do. So again, I call this the prime factorization method. Okay? Because what we're going to do is we're going to take what's under the radical and we're going to prime factor it. Now, I'm starting off with a very small number, so the square root of 20 being our first one. So the first step, okay, is just to simply find two factors of 20, okay? And so in this case, I'm going to just use the square root of 2 and 10. 2 times 10 is 20. Okay, so, and I do go ahead and keep the radical over it the whole time, the square root symbol there. That way you don't lose it. Now, when you look at this, since we're doing prime factorization, hopefully you remember what prime is. It means that I'm going to take it down so that the only number that'll go into it is 1 in that number. So 2 is prime, 10 is not prime. So I'm going to take this one more step, and I know that 10 is 2 and 5. Okay, so now all three of those numbers are prime. The easiest way that I have found that I think tends to make more sense to kids when I tell them this is, remember this number is an understood 2. And so what that's telling me is that I want to group my factors in groups of 2. Okay, because remember, square root means what number times itself twice will give you what's under the radical. So in this case, 2 times 2 is 4 on there. So, but what I tell the kids is to do, since it is a square, then I group this in groups of 2. Okay, so another way I tell them is, think of it as this. You can go outside to play if you have a partner. Okay? Maybe your mom says, well, you can go to the movie, but you got to take somebody with you. And so if it's a square root, then we have to go in groups of 2. Okay? So I have a group of 2s, and that group of 2s can go outside and play. Okay? But when they go outside, it's one group. Okay? I have one group of 2s. And so when that comes out, it comes out just as a 2. And then 5 does not have a partner. He cannot go outside to play. Therefore, he must stay inside. Okay? Now, mathematically, what does this mean? Well, again, 2 times 2 is 4 and 5. Okay? And I know that the square root of 4 is 2, the whole number. And then there is no square root of 5, and there's my answer. So however you want to look at it, when I give you a bigger one here in a minute, maybe that will make more sense on there. So that's what I call the prime factorization method, okay? It's because I want a prime factor, and then I want to take them out in groups of 2, okay? So the next one we're going to look at is what I call the largest perfect square. Okay? And in my mind, this is more of a mental thing. So you're going to kind of keep things in your head. And sometimes I have a little trouble keeping them in my head. And if you can't keep it in your head, then you can write it down. But what I'm going to do is I want to go through that list. Remember that list that we had earlier that was all of our perfect squares, okay? And sometimes if you're doing this what you might want to do is put those perfect squares across the top of your paper. So 1, 4, 9, 16, 25, 36, 49, so forth. Okay? Put those across your top of your paper. So what I'm looking at here when I do the largest perfect square is I'm looking at those values and I say which one of those numbers is the largest number will go into 20. 20 is not very big, so it's pretty easy to figure that one out. And you say, well, you know, obviously anything past here won't go for sure because that's bigger than 20. And so we only have 4 numbers to look at. We never look at number 1 because that's not going to do us any good. And so in this case, it is 4. And so I go ahead and I break this apart into my 2 factors this way. Square root of 4, square root of 5. And I apologize for my square root symbol. I get going fast and I don't make it really look right. But anyway, square root of 4, square root of 5. And then we know square root of 4 is 2. And then the square root of 5 is not a perfect square, so it stays that. And so that's all you got to do. Okay? But sometimes, according to how big the number is, finding that largest number takes a little bit. Okay? So I'm going to try to run through a couple more. I know this video is going to get a little long, and I apologize for its length. But so I'm going to start with 392. And I'm going to first do it by prime factorization. So I'm going to go ahead and do this. I probably should have left me more room both ways. So I'm going to start with 392. It is an even number, so I know 2 will go in there. And so I can just real quickly, hopefully divide that in my head. So that would be 1 left over, be 9, 18, 1 left over, 196. There we go. 2 and 196. Okay, and you can use your calculator. I don't have any trouble with you doing that. What I don't want you to do is those of you who have a calculator that will give you the answer in one fell swoop. I don't want you to do that. Okay, so 2, and again, this is even, so I'm going to go ahead and do 2 again. And 2 into 196 will go what? That's 9 is 18, 98. Okay, you guys can check my math. And I'm just going to keep doing that. There's 2 and 2, and I know 98 is also even, so I got another 2 that will go in there, and that'll go 49. And then 2, 2, 2, and now I'm breaking 49 down to 7 and 7. So there is a prime factor, okay? So here's what I told you earlier. We're going to take them out. You can go out if you have a partner. So I'm going to just circle these. I have a group of 2s. This 2 does not have a partner. It's going to stay. And I have a group of 7s. So since the 2s have partners, they can come out. It only comes out as 1, 2. And the 7s can come out. I have one group of 7s that went out to play. Okay? And when I take those out, what's all left is the 2. Okay? And then what I do with the front 2, this is a multiplication when they're out here. So that's 14 square root of 2. Now I told you earlier you can check that because if 14 squared times 2 should be 392. And you can run that in your calculator and check it. But it actually gives me the 196 and 2 that I started off with as my first factors. Okay? So you can do a check on that. Now, with that being said, since we've already somewhat did this, okay, this is prime factorization. If I do the largest perfect square on there, and I went through that list that I gave you earlier up here. Now, I didn't go all the way with it. Oops. This thing will not sit very well. But if I had kept going, there's 49. That's 7. I would have got 81, 100, 121, 144, 169. Remember that list. 196, so forth. And you see, right there's that 196. So when I come to here and I say, okay, well, what's the largest perfect square that is in 292, 392, then I would say it is 196. Okay? And again, I'm going to go ahead and write it the way I showed you earlier. So when I do the perfect square method, and I like putting the perfect square first, and then what's the second number here? Because when I take the perfect square, the square root of 196, I just wrote that. That's 14. And then the square root of 2 left. And see, then I save me some of this work here. Now, what could also happen is you could be prime factoring it, thinking you're going to do the prime factorization method. But as soon as you hit a perfect square, stop. Some of you may not have saw the 196, but what you might have recognized is the 49. So some of you might have stopped right there and at least got your 7 out in front, and then you could have grouped up your 2's. Okay, so there's multiple places you can stop at on those, but that's doing it both ways, and hopefully that doing that grouping that I was showing you makes more sense when there's more numbers there. So again, if you have a partner, you can come out and play, but that it's only one group that goes out to play, and some kids really like that strategy. Let's do this one here real quick. Again, I'll start it with prime factorization. So again, it's even. 2's going to go in it. That's going to give me 2, 2, 4. And then I'm going to keep going with 2's. So that's 1, 1, 2. And that's still even, so I can still take out a 2 there. And that's going to give me what? 5, 10, 56. I'm going to keep going. 2, 2, 2. 56 is 7 and 8. I'm going to keep going. And 8 is 2 and 4. And then, and again, 2, and then 2, and 2. Okay? Now, what you might want to do on this one is to rearrange and put all your 2's together. So I have 1, 2, 3, 4, 5, 6, and then the 7. Okay? Now, when I go to grouping, okay, I have 1 group, 2 groups, and 3 groups of 2's. So when they come out, I have 1, 2, that's the first group. I have 1 group of 2's, another group of 2's, and another group of 2's. And those are all multiplied together. The 7 is left under the radical because it does not have a partner. And then I multiply these 3 together. So 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. And this is 8 square root of 7. And I'm done. Now, this is where prime factorization, if you're doing this step, becomes a very long problem. Okay? But let's go back in and look at it in terms of perfect square. Okay? And so, again, I'm going to take my computer. Let me just show you how I'm going to do this. Okay? And I'm going to take that list of perfect squares that I had up here. Okay? And my number's 448. Okay? Let me just write this here. And I'm going to just run it in my calculator real quick. Okay? And I'm going to say, okay, will 4 go into 448? Well, yeah, it will. That one will go. Yes. But look how big my number is. Let's keep going. And then will 9 go in there? Will 16 go in there? And I would keep going up, and I'm just going to real quick take that in my calculator, 448 divided by 16. Okay? So here, I've got my phone here. And so I'm going to do real quick, let me clear this out. I'm going to do 448 divided by 16. And it does go. It's 28. So 16 also goes in there, but there's 28 left over. So again, I'm going to keep going. So I might do 448 divided by, what would be another nice number? 36 might go in there. No, that one doesn't go. So I know 25 is not going to go. I know 9 shouldn't go because remember those have to add up to be a number divisible by 9. Our rules. 36 didn't go. 49 doubtful. 448 divided by 49. No, it doesn't go. And I'm going to keep doing that. I'm going to keep going all the way up until I find something that that goes in there. You know what I did? Notice I did here. Did anybody else notice that I skipped that 6, 7, and I skipped 8. I skipped 64. And so I'm going to try 64. Yes, 64 goes in there. So I know 64 goes in there. Okay? And it goes in there 7 times. Now, I know I need to stop. How do I know I need to stop? Because it's 64 times 7. And the number that's left over here is very small, and it's prime. Okay? That's how I know. When I put 16 in there, I forgot what it was. Let me just go back real quick. When I took that and I divided it by 16, okay? When I divide by 16, it was 16 and 28. Okay? Look, 28 still has a perfect square in it. It's 4. We know 4 times 7 is 28. So, because that 28 was not prime, and it didn't have and it still had a perfect square in it, I knew I wasn't done. on that one. So anyway, let's go back down to our problem. 448, we said it was 64 times, so I'm going to go ahead and do it the other way like I showed you. 64 times 7. Okay? And again, I always put my square root first, my perfect square first, because when I take the square root of 64, it is 8, and the square root of 7 is what's left over. Okay? Same answer, either way you go about it. This one is probably more mental, somewhat, because you're kind of keeping in your head. Or you, again, could do your list. Okay? The only problem with marking off your list is then when you go to do your next set of problems, you'd have to rewrite your list again. Okay? On there. So you might not want to mark through your list. You just might want to just kind of track yourself as you're going down through there. Okay? So that's 2 examples. I'm going to work some more for you. You're going to work some more. But hopefully, if you feel comfortable with it, you want to go ahead and take off and try some on your own, then by all means do that. If not, there'll be another video coming up in which I show you some more of these.